Section 2.7 is on the curve fitting with linear models. And our couple of vocab words here. The first one is regression. That's the statistical study of the relationship between variables. So we're going to have two different things that we're going to compare. And the statistical study of those two things would be called a regression. Correlation is the strength and direction of the linear relationship between the two variables. So if it's a positive correlation, we're going to have a scatter plot where the dots are moving upward when you look at it from left to right. Negative correlation would be when you look at it from left to right, the dots are going to be going in a downward slope. And then no correlation is where the dots are just all over the place. It's not going up, it's not going down, they're just everywhere. So line of best fit is the line that best fits the data. It can be used to make predictions. So I will show you how to kind of estimate the line of best fit, and then I will show you how to use the calculator to find that as well. So example 1 says Akron, Ohio and Wellington, New Zealand are about the same distance from the equator. Make a scatter plot for the temperature data, identify the correlation, and then sketch a line of best fit and find its equation. So they give us the average temperatures for each month in both cities. And step 1 would be to plot those. Well, when you plot those, the first thing listed is your X and the second thing listed is your Y. So I copied the picture here that was already done. And your scatter plot would look similar to this. And I just thought this would be easier than me trying to draw it out and freehand here, so we get a little more accurate representation. Step 2 is to identify the correlation. So looking at those dots for left to right, they go downhill. So this would be a negative correlation. And then step 3 is to sketch the line of best fit. It says sketch. It's not going to be perfect. You're going to take a ruler or straight edge of some sort and try to separate the dots so that you have the same amount on top of the line as you do underneath of the line. It is okay to go through a couple of the points, but you want to try to fit it as best as possible. And here it is drawn for you, and you can see it goes through the two blue points there. Step 4 is to identify 2 points on the line. So if you're doing this by hand, you definitely want it to go through a couple of the points. So this particular line is going through 30, 70, and 80, 52. And then we're going to use those two plots to find the slope of our line. So we're going to do y2 minus y1. So we're going to do 52 minus 70 and x2 minus x1 at the bottom. And 52 minus 70 is going to be a negative 18, and 80 minus 30 is going to be 50. Those are even, so I'm going to cut them in half. We're going to have negative 9 and 25. So the slope of our line is negative 9/25. Then for step 6, we are going to plug into point slope form and then use that to put it into slope intercept form. So our point slope form was y minus y1 equals m times x, the quantity of x minus x1. So we just figured out our slope was negative 9/25. And we're going to pick one of these 2 points. I'm going to pick 30 and 70. So our x is 30, so I'm going to put that over here. And our y is 70, so that goes here. Now we have to distribute that negative 9/25. So we're going to have y minus 70 equals negative 9/25 x. And a negative times a negative is going to be a positive. 9/25 times 30 is going to be 10.8. And then we're going to have to add 70 to both sides. So So we have y equals negative 9/25. Since that 10.8 is in decimal form, I'm going to write this in decimal form. It's negative 0.36x, and this would be 80.8. So that is the formula for our line of best fit on this graph. And we can use that to predict other points that aren't given. It's not going to be an exact answer of what exactly is going to happen, but it's a good idea of what could happen. Next is correlation coefficient. That is the letter R, and it's a measure of how well the data set is fit by a model. So looking at this chart, R is the value in the range -1 to 1. So your R value can only be those numbers between -1 and 1. So if R is equal to 1, the data set forms a straight line with a positive slope. So if you look down here at the right-hand side, I'm looking at this one, the R value is about 0.95. Those dots are pretty close to a straight line, but not quite. So if the R was 1, it would be an exact straight line. And then the same thing goes down here for -1. It would have a negative slope, but they would be in a straight line as well. And when R is negative 0.95, they're pretty close to a straight line. They're grouped together, but not quite, and with a negative slope. And then when you get close to R is 0, there is no correlation. So as you get closer going through the negatives or going from coming down from the positives, the closer you get to 0, the more spread out the dots are going to be. And when R is exactly 0, there is no correlation. All right, so you can use a graphing calculator to perform a linear regression and find the correlation coefficient. To display the correlation coefficient, you may have to turn on the diagnostic mode. To do this, press second, then 0, and then choose diagnostic on mode. So for those of you in face-to-face, we are going to have to check that out on your calculators to make sure that setting is taken care of. For those of you at home, you can use the Desmos graphing calculator and you don't have to do any of this. So to graph a scatter plot and the line of best fit, these are the steps we're going to use in face-to-face class using our graphing calculators at school. For those of you online, the graphing calculator I'm going to show you here does all of the work, and it's pretty simple. So example 2, anthropologists use known relationships between the height and length of a woman's humerus bone, the bone between the elbow and the shoulder, to estimate a woman's height. Some samples are shown in the table. So as you remember, the first thing listed is X and the second thing is Y. So we could graph this out on a scatter plot by hand, but our calculator does this for us. And it's much easier and faster this way. So if you go to the Desmos graphing calculator and you click the 3 bars over here in the left-hand upper corner, you have all of these different choices for types of graphs. So I went and I found one that looked like a scatter plot with a line through it, which is right here. There it is at the very top. And that's what I picked. And then it opened up this for me. And it said data set 1. So I went ahead and typed in the X values and the Y values out of that chart. There were already numbers there for us. I just deleted them out and retyped in the ones from our problem. And then if you scroll down, whoops. Once you put those dots in, it plots those dots on the graph and it automatically puts the line of best fit on. And if you scroll down, here is the R value. The R value is 0.9912, so that's pretty close to a 1. So the dots are going to be pretty close to a straight line, as you can see. And then this is in the form of y equals mx plus b. And down at the bottom, it says parameters here. And m is 2.75388 and b is 71.9738. So we can use those to write our equation in slope-intercept form. We don't have to find our slope by hand. We don't have to find the y-intercept by hand. This is all given to us right here. So our equation, and I would round to the nearest hundredth when you're doing these. So our equation is going to be y equals 2.75x plus 71.97. I'm just going to double check that. Yep. Rounded to the nearest hundredth. So Desmos graphing calculator does it all for you right away as long as you check that and type in your information. Then we're going to use that equation to predict this woman's height whose humerus bone is 32 centimeters long. So I am going to take 275 and times it by 32, since x is our humerus bone length. And then we're going to add that 71.97. And when I type that into my calculator, I get an answer of about 159.97. So this woman with a 32 centimeter long humerus bone is almost about 160 centimeters tall.